next lecture. Okay. Now, for tutorial 1, we have uploaded to the Moodle. Now, for the first question, it is about the momentum conservation or momentum equation. Okay, sorry, the static hydrostatic force. Hydrostatic force. To estimate how much is the force exerted on the plane in this figure, in this setup, okay? Find the location of the resultant force. Find the location of the resultant force, F, on the water on the triangular gate, the force P, and the force P necessary to hold the gates in the position shown in the figure. Neglect the weight of the gate. Okay. Now here is supposed to be a water tank. All right. It's an inclined wall, and then there is a triangular gate here, just like the water is kept. Oops. Okay, the water is kept on the left-hand side, right? And there is a triangular gate. This is the hinge. That the gate can be opened like this way. Okay, can be opened like this way to let the water comes out. Okay, the gate can open like this way. All right, so let the water comes out. Now, here we are estimate. Okay, how much is the P force to hold this gate in place, and where is the location of the center of pressure? Okay. Now, to estimate this kinds of the question for the hydrostatic force on the plane, we mainly have 3 steps. Okay, 3 steps. One is the hydrostatic force, the resultant force, or the and the second step, it is find the center of pressure. The third step is to use the moment equilibrium. To find the unknown force, okay? So, very first step, the resultant force. Remember that for the resultant force, the pressure force, resultant pressure force, is calculated by the average pressure on the plane and times the area, and equal to the centroid pressure times area, okay? Now go back to the figure here, okay? Now, this is the shape of the triangular gate. For the triangle, here, okay? For the triangle, the centroid is located at the center line, on the center line, okay? On the center line from this vertex to the bottom, the baseline, okay? And on this line, and then the height is 1/3 from the baseline, okay? 1/3 of the height from the baseline. So that the location of the centroid is located the total height of this triangle is 3 meters. Okay, so that the centroid is 1/3 from the bottom is 1 meters from here. Okay, so that is 1 meter from the baseline. It may be here. Okay, it may be here. So this length is 2 meters, and this is C point. Okay, and this length is 1 meter. All right. So that we need to look for the HC. We need to look for the HC. Suppose that the water surface is PATM. Okay, the water surface is PATM. And then we may look for the point C pressure by the raw water, the G and HC times the area of the plate, the triangular gate. Okay, HC is not directly given, but we can see that in this triangle. Okay, in this triangle, HC can be determined by the hypotenuse, by this edge, 5 meters times 5 meters plus 2 meters times the sine 53. Okay, so the HC can be determined by the rho G. It is 2 plus 5 meters times the sine 53 degree. Okay, HC can be calculated by this way. And the area. Now, the density of water can be estimated by the water density can be, we assume that it is 1,000 kg per meter cube. Gravity is 9.81, or we may directly use the rho G, the gamma. The specific weight is 9810 to save time, which is 1,000 times 9.81, okay, times 7, all right, 7 times sine 53 degree times the area of this triangle. So it's supposed to be the bottom width is 2 meters and the height is 3 meters. It is a right triangle here, okay? So it's like the 1/2 times 2 meters times 3 meters, okay? For the area, for the resultant force. The resultant force is calculated to be, it's not given in the bottom answer, we can do it by ourselves. So it's 9810 times 7 times 3 times 53 degrees sine. It's about 164.5 kilonewton. It's around 164.5 kN, okay, kilonewton for this resultant force. Next is the location of the center of pressure, okay, center of pressure. Now, the center of pressure we can see from this figure, okay, or here. The center of pressure, CP, is this point. As we said, the center of pressure is the action point of the resultant force or the pressure force, which is supposed to be lower than the a little bit lower than the centroid, and we estimate the distance from the center of pressure to the water surface. Now, from the centroid to the water surface, this is YC, and from the center of pressure to the water surface, this is maybe I use different color to make you see it clearer. Use purple. Okay. This is YP. All right, purple to the COP, to the CP is YP, okay, or YCP. Now, this is the center of pressure. The location of center calculated from this location. Now, the YC is 5 meter plus 2 meter. Okay, YC is 5 meter plus 2 meter. The center of pressure. Now, firstly, we see that the YC is 2 plus 5 meter. Is 7 meter. Okay. The YP supposed to be the center of pressure equation, YC plus IXXC over YC times A. Now, YC is have been determined. Area is calculated as 3 square meter. IXXC, it is the calculation based on this. AB cubed over 36. AB cubed over 36. A is the bottom width of the triangle. B is the total height. Okay. Or we can try to use it to simplify the calculation. Is AB cubed over 36. YC times the area of the triangle is A times B over 2. Alright? Canceling this, become 2. And this becomes 18. Okay, power 2. So it's B power 2 over 18. So that we can calculate the YP is like 7 meter plus is B squared. B is totally 3 meter over 18 times 7. Okay, YC 7 or 7 times 18. Okay. So the result is determined to be 7.071 meter from the surface. Okay. Number 3, to find the force P necessary. For example, it may be a stopper. Okay, you may have a stopper to control the opening and the close of the gate, so that you may need to estimate how much is the force necessary to open it or close it. Okay. Right? Now, moment equilibrium, we can see from this figure. So, the solid line indicates that the gate's location, okay, this distance is 5 meter, and the YP is 7.071 meter. So that this length for for this this location, okay? This part is 2.071 meter. So because we need to estimate the moment for the F times the to the hinge point here, okay? To the hinge point here. So that this distance is, we can say is 3 meters subtract 2.071 meter, alright? So for the moment equilibrium, the F is making the rotation of the gate is to be the clockwise, okay? The P is making it rotating counterclockwise. So the relationship is the F out, the resultant force times the 3 subtract 7.07 2.071 is equal to the P force times the moment arm, which is 3 meter. So the P is therefore calculated as like the F out, which is 164.5 kilonewton. We can times the 3 subtract 2.071 and over the 3 meter, and this one is found to be about 50.9 kilonewton. Okay, it's about 50.9 kilonewton. All right. So this is the location, the force P necessary to hold the gate in place. However, it's not all finished, because the question is also asking us to find the location. Now, because the center of pressure is not is on the center line, okay? So we need to locate we have located the vertical location, which is 2.71, all right, from the vertex. However, the horizontal location is unknown, okay? Now we can magnify this triangle, okay? We can magnify this triangle. This is the right triangle. The CP is on the center line, okay? Supposedly this is the centroid. We may use the similar triangle, okay? Or maybe we can directly use this one, okay? If this point is CP, we can use similar triangles method. The total, from here to here is 2.071 meter. From here to here, the total height is 3 meter. All right. Now, you can estimate how much is the distance here. Okay. The distance from the bottom line, the bottom edge is half width is 1 meter. Okay. 1 meter, because the total width is 2 meter. Half width is 1 meter. So that is to find out the horizontal coordinates for the center of pressure. The vertical location is 2.071 from the on the center line for this top vertex point. Okay, for the similar triangle. Now, the 2.071 over 3 meter is equal to the x location over 1 meter. Okay, so the x is found to be about 0.690 meter from any one of the side. Okay, any one of the point, because this one. This one, okay, is 0.690. The y location is 2.071 from the vertex, all right? So to locate the x is 0.690 from one of the h, okay? So this is the solution for the problem 1. For the question 2, there may be very long solution steps, so I will talk about the question 3 first. Then we will talk about the question 2 later, next time, okay? Question 3, a glass tube is inserted into a flowing stream of water with one opening directs upstream, and the other vertical. If the water flow velocity is 5 meters per second, seems that there is conflict, okay? Here is 5. Here is 5. Figure shows 4. Okay, we use 5 meters for calculation. How high will the water rise in the vertical length relative to the level of the surface of the stream? Okay, so it is asking how much is the the water level difference. Actually, we have analyzed this situation in the lecture, okay? Now, here is location 2. We say the location 2 here. Any one of the point dots before it, we say it's location 1, okay? In this figure, we may use the Bernoulli equation. Bernoulli equation. Bernoulli equation. The full Bernoulli equation is the P1 over gamma plus Z1 plus V1 square over 2G is equal to the P2 over gamma plus Z2 plus V2 square over 2G. Right? Now we can analyze now. The Z1, Z2 are cancelled due to the same location, same elevation. Okay, same elevation. They are cancelled due to the same elevation. All right. V2 is static. Okay, stagnation point. Cancel. Okay. Is 0. This is due to the V2 is a stagnation point. V2 is static because it is in the front or on the intersurface between the flowing fluid and the tube, the stationary fluid, so that the V2 is 0 velocity here. Okay. So this equation can be simplified to be the P1 over gamma plus V1 square over 2G equal to P2 over gamma, all right? Now, we see that the P1 over gamma, if we say this pressure at point 1, it is contributed by the water pressure, static pressure. Okay, so the P1 over gamma. P1 is rho G A1, rho G A over gamma, right? Plus V1 square over 2G is equal to P2. P2 is contributed, the pressure is contributed by the liquid in the tube. It's not just the rho GA, okay? It's the rho G, the height is from this top level, okay? Is L plus A, all right, over gamma. Now gamma cancels that the rho G, so the remaining is, all right, the remaining is A plus, it's V1 square over 2G is equal to L plus A. A and A are cancelled. So the V1 is, the L is equal to V1 square over 2G. L is equal to 5 meters square over 2G, 2 times 9.81. And the result is found to be 1.27 meter. Okay, 1.27 meter. This is a straightforward question to analyze the using the Bernoulli equation. Okay. Now, so this is also indicates that for the velocity measurement, okay, we can use that the L times the square root 2GL, okay, in this situation to measure the velocity height. V1 is equal to square root 2GL in other words, okay? So that's why we can use the pilot tube to measure the velocity of the flow in here, okay? So, and also, now additionally, if there is a zero configuration, now you can see that in this point, for the location 2, you can see here. For the location 2, or for the location 1, maybe location 1. This is Z1, okay? And this is A is equal to the P1 over gamma, alright? Now, the V square over 2G is equal to the L. So that the V square over 2G, V1 square over 2G is the height of the L, the same. Alright? So that we see that the water level in here, it represents that the distance here actually represents that the P1 over gamma plus Z1 plus the V1 square over 2G, which is the HGL. EGL, the AGL's level, okay? And the water level here, and the visible flow water level, okay? It is calculating the P1 over gamma plus elevation 1. Okay? So that the visible water level, it represents that the HGL, the hydraulic grade lines level. And if you use the pilot tube to measure it, okay, the level, the absolute level for the water in the tube indicates that the EGL's level, energy grade lines level, and it represents the total energy. Total head, okay? And this HGL represents the piezometric head. Or we can say this piezometric head represents the potential energy, okay? Represents the potential energy. So, so that that's why when you are plotting the sometimes that you see in this figure. That's why in this figure, okay, for the energy grade line, in here, okay, in this figure. So that's why if there is a stagnation tube or the pilot tube inserted into the pipe, that the water level will be higher than the simple manometer. Simple manometer represents that the pressure head, okay, the pressure head, and together with the elevation, it means that the piezometric head for its visible water level. And if for the stagnation tube or the pilot tube, the visible level, visible water level indicates that the height of the EGL, because it adds the additional velocity head level. Okay. Now I think that the time is just come to here for the tutorial session. So here is this is all of the content that we deliver for the lecture tonight and the tutorial tonight. Okay. Now the question 2 will be talked about next time. All right. So if you have any further question, you can stay behind and discuss with me.